Welcome back, physics fans. Today we're going to talk about momentum and impulse. The word momentum is derived from the Latin movimentum, which means movement. Momentum is a vector that quantifies the motion of a particle or system of particles. As a vector, it has both magnitude and direction. We express momentum p as the product of the system's mass m and velocity v. In his Philosophiae Naturalis Principia Mathematica, Sir Isaac Newton first described his second law of motion using momentum. Newton famously stated that force F is equal to the first-order time derivative of momentum. If we assume that the mass of a system remains constant, we can take the derivative of velocity and arrive at the more familiar expression of force is equal to mass times acceleration. Now let's consider changes in momentum due to collisions. If two or more systems of particles collide, we describe the change in motion through impulse. Impulse, J, is also a vector and is defined as the product of the average force exerted on a system, F average, and the duration over which the collision occurs, delta t. If we hold F average constant and increase delta t, the impulse will also increase. Alternatively, if we hold delta t constant and increase F average, the impulse will increase proportionately to F average. We're now ready to combine our understandings of momentum and impulse into a single physical relationship. Remember that, per Newton's second law, force is the change in momentum divided by a change in time. Let's assume that the change in momentum we are describing occurs over the same time duration as the collision described by the impulse definition. If we substitute Newton's second law for F average in the definition of impulse, we find that the duration of the collision, delta t, cancels with the change in time described in Newton's second law. What we're left with is a relationship between impulse and momentum, which states that impulse is equal to the change in momentum experienced during a collision between two or more systems of particles. And there you have it, physics fans. If you have any more questions, please direct them to your instructor. As always, may drag be negligible and the net force be with you.